So this is calculating the rate law for a reaction. So in this one, here's the example. 3 experiments conducted at a specific temperature for the following reaction. Now remember, the rate law cannot be determined by just looking at the chemical equation. It has to be experimentally done. So here is 3 experiments using the same type of material, and we're going to do a rate comparison basically. Okay, so now what we're going to do is we're going to find the first one. It says what the rate law. So we're going to have to find the rate law for each one. So now notice that we can look at this and we notice that these two concentration is the same and these two concentration is the same. And there's a reason for that. Because when we put it into the rate law, we can actually take those out. So I'm going to compare the first one. So to compare 1 and 2. So we know the rate of experiment 1. Okay, so the rate of experiment 1 is equal to, remember, K, concentration of the NO, and then the concentration, the NO to the N, the M power, and then concentration of the H2 to the nth power. Now we don't know what M and N is because, you know, this is what we're trying to find. We're going to compare that to the rate number 2, and in the rate number 2 we have K, the concentration of the NO to the M, and then the H2 to the N. Okay, so now what we're going to do is we're going to take the amount here, we're going to plug it in. So now notice that in the second part, okay, we're going to go down the second part, the rate now is, for the first reaction, is 0.0900 molarity per second is equal to K multiplied by the concentration of the NO, which is 0.2. So this is 0.2 molar raised to the M. And then the H would be 0.3 molar raised to the N. Now we're going to do the same thing for the bottom part. Okay, so we'll divide this by the rate 2, which is 0.0025. 0.0225 molarity per second is also equal to K. The concentration now is, instead of 0.2, it's now 0.1. So 0.1 molarity, and we'll raise that to the M. And then the H plus is 0.3 molarity raised to the N. Now notice something. The K here, because they are on top of each other, they can cancel out. Notice also the 0.3 milliliters, the 0.3 molarity raised to the nth is the same. So we can actually cross that out. So now all we have is the difference here, which is 0.2 over 0.1, which is basically 2, right? 2 raised to the M. And when we divide that, we get something like 4. Okay, so 0.09 divided by this, we get 4. So basically is 2 to the M is equal to 4, so M must equal to 2. So we know that M is equal to 2. So in this case, we already found out what M is. Now we need to find out what N is. And to do the same thing, what we're going to do is we're going to try to get M to go away. So if you look at equation 2 and 3, in that part, the M is going to go away, right? So I'm sorry, the NO is going to go away because they have the same concentration. So we're going to do the same thing again. So now we're going to basically go the rate of the 2 over the rate of the 3 is equal to K. Rate of the 2 is, of course, NO to the M, and then H2 to the N over K, NO to the M, and then H2 to the N. So again, all we have to do is plug in those numbers. Right? So the rate for 2 is 0.0225 molarity per second over the rate of 3, which is 0.0150 molarity per second, is equal to K, concentration of NO. Whoops, I have that concentration now, right? I don't have just NO anymore. Of that, basically 0.1 molar raised to the M, and then concentration of the H2, which is 0.3 molar raised to the N, divided by the third experiment, which is K, concentration of 0.1 molar raised to the M, and 0.2 molar raised to the N. So now again, notice that the K will cancel out, the 1.1 molar M will cancel out, leaving was this. So now that all we have this is 0.3 over 0.2. Okay, this is equal to 0.67. It's equal to basically 0.3 or 0.2 is 1.5, correct? Okay, to the nth power, right? So in this case, what we're going to do is we're going to find out what that is, right? So you can do the reverse of that. So here you find n will be equal to 1 basically. Alright, I'm wrong here. This right here, the 0.0225 divided by 0.015, this is 1.5. So here, notice now n has to be 1, okay? So that 1.5 equals 1.5. So n is 1. So we now know n is 1. So the rate law would then be rate is equal to K, concentration of the NO, and NO is to the M power, which is 2, and concentration of the H2, which is the N, which is concentration of the first power. So first power, we're not going to set anything. So there's the rate law. Okay, so now if we find the rate constant at this temperature, all we have to do is solve for K. And by doing that, all we're going to do is, we can take any one of this. I will take part 3 here, okay, and I'll plug it in. So here I would have the NO, which is 0.01. We have the H2, which is 0.2, and we have the rate, which is this, and I can solve for K. And then the order of the overall reaction is just adding those two. So the overall reaction here would be 2 plus 1 here. That makes it 3. So the overall is 3. So if you have any question, make sure you ask in class.